Can humans grab a tiny asteroid and turn it into a spaceship, mount instruments on it, then let it sail out of the solar system, just like Comet 2I, Atlas did? This isn't wild imagination. Astronomers have actually proposed similar ideas, and that idea comes from a small, mini-moon near Earth. You might remember that in 2024, Earth welcomed a temporary mini-moon, but that one was just a passerby, orbiting Earth for only 2 months before slipping away. Hard to catch. But now astronomers have found something else, another tiny asteroid, that is believed to have followed Earth for a full 60 years. And the key is, it's not a regular visitor. It's classified as a quasi-moon, a very rare type of celestial object. Are quasi-moons just like our real moon? The answer might surprise you. They're not like the moon that orbits Earth. A quasi-moon doesn't actually orbit Earth at all. It truly orbits the sun, but its orbital rhythm is perfectly synchronized with Earth's, like someone who runs a marathon with you, always matching your pace, not ahead, not behind. And that's what matters most. Its orbit is stable, making it easier to catch, because the real universe is nothing like the calm sky we see above. It's absolute chaos. The sun, moon, Earth, and every other planet are constantly tugging on each other with gravity. Even small asteroids aren't exempt. Most asteroids can't maintain such delicate balance for long. They either get pushed into new orbits, pulled toward Earth, or flung into deep space. That's why finding even one or two that can maintain this special motion is incredibly rare. Together, they belong to a broader family called co-orbital objects. Astronomers further classify them based on how they move relative to Earth. But these cosmic companions don't stay forever. Some stay with Earth for decades, some for centuries, but eventually gravity nudges them away. Most quasi-moons are tiny, about the size of a building, sometimes even smaller. They're extremely dim, almost invisible among the stars, but their scientific value is huge. Through them, astronomers can study how near Earth small bodies move, and how long they can remain gravitationally captured by Earth. And that's where the bold idea comes in. Scientists started to imagine using quasi-moons as stepping stones for space exploration. Right now, scientists believe that in theory, quasi-moons could be used this way, because their orbits appear synchronized with Earth. They're easier to reach than typical asteroids, but developing them still requires solving major challenges like orbital control and propulsion. In the future, they may truly become humanity's stepping stones to deeper space, and Earth has had companions like this before. The most famous one is 2016 H03, nicknamed Earth's constant companion, only about 91 meters across, yet it has stayed near Earth for nearly a century, and could remain for several more. So if human scientists have thought about modifying asteroids, then, at least from a science fiction perspective, an advanced civilization could theoretically modify comets as well. But for now, that's pure speculation, with no observational evidence at all. And the quasi-moon we're talking about today is named 2025 PN7. It is expected to stay for about 68 more years. Why didn't we find it earlier? Because it's ridiculously small, only about 16 meters in diameter, roughly the length of a bowling lane. And that answers another question. Even if you know exactly where it is, can you see it with the naked eye? Absolutely not. Its origin is still a mystery. Astronomers haven't determined its composition. The only thing we know for sure is its orbital path. Quasi-moons may come from several sources. Some are near-Earth asteroids that happen to enter stable co-orbital orbits. Some may be fragments of the moon. For example, another quasi-moon named KAMOOALEWA has reflective properties nearly identical to samples brought back by the Apollo missions. Some researchers think it might be ancient lunar debris, ejected by a massive impact. The mini-moon 2024 PT5 also showed similar clues. Its surface composition resembles lunar basalt, suggesting it may also have come from the moon. So how do these quasi-moons stay synchronized with Earth? It's actually an orbital illusion. Remember, like all quasi-moons, 2025 PN7 doesn't truly orbit Earth. From Earth's perspective, it looks like it's drawing lazy loops in space, cosmic doodles, never falling too far behind, never drifting too far ahead. Astronomers call this a one orbital resonance, meaning the time it takes to orbit the sun is exactly the same as Earth. 1 year. If these fake moons are so close to Earth, why doesn't Earth's gravity pull them in? Especially since they're small and seem within reach. Because despite being classified as near-Earth objects, they are actually very far away. The moon is about 384,000 kilometers from Earth, but quasi-moons orbit the sun millions of kilometers away, far beyond Earth's gravitational grip. So how big is Earth's gravitational domain? That brings us to something called the Hill sphere. Within this region, Earth's gravity is stronger than the sun's. Think of Earth's gravity as a bubble about 1.6 million kilometers wide. Any object inside the bubble, like the moon, can be captured by Earth, leave the bubble, and the sun takes over again. The mini-moon 2024 PT5 worked exactly like this. It briefly entered Earth's hill sphere, got captured as a temporary mini-moon, but because it was small and fast, it slipped back out, and the sun pulled it away again. Besides quasi-moons and mini-moons, there are also horseshoe orbit objects. These asteroids stay near Earth's orbital path, but from our perspective, they first move ahead of Earth, then slow down, then drift behind Earth, looping over and over, like an unmarked police car tailing you, switching lanes, doubling back. Impossible to predict. Plot their long-term motion relative to Earth, and you get a giant horseshoe shape, hence the name. And we're not done yet. There are also Trojan objects. They don't hover near Earth like quasi-moons. Instead, they hide at two special points, 60 degrees ahead of Earth, and 60 degrees behind Earth along the orbit. Imagine riding a bike, one friend far ahead, one far behind, all pedaling at the same speed. That's how Trojans move. These spots are called Lagrange points, where Earth and Sun's gravity balance perfectly. Objects that fall into these zones can stay there for millions of years. Jupiter has tons of these hitchhikers. Earth has only a few. There are even weirder tadpole orbit objects, which don't sit still in Lagrange points, but make looping, bean-shaped trips around them. And if that's not enough, there are jumping Trojans, cosmic indecisive wanderers, that can't pick one Lagrange point. They stay thousands of years at the front point, drift to the back point, then slowly drift forward again. Rare and astonishing. So while we see only one moon in the sky, Earth actually has a whole squad of tiny cosmic companions. Some loop around, some tailgate us, some hide quietly in the corners of the orbit. They may not compare to the real moon, but they still have value. Every new quasi-moon we discover helps us understand how small objects survive in a chaotic universe. By studying our celestial neighborhood, we also learn more about Earth itself, and they push space exploration technology forward. So what do you think? In the future, will we use asteroids and comets as probes? And could an alien civilization already be doing this? There's no evidence, but feel free to open your imagination in the comments. Let's explore some sci-fi possibilities together.